Hello guys, welcome back to the universe of TechUp. In this tutorial, we will learn about selection sort. First, we need to learn what is selection sort, then key characteristics and why use selection sort and applications of selection sort, how it works, and also discuss real life examples and algorithms. First, what we need to do is what is selection sort? The selection sort is the straightforward comparison based sorting algorithm that sorts an array or list by repeatedly selecting the smallest or largest element from the unsorted portion and moving it to the beginning or end of the sorted portion. What it tells means sort is a simple and intuitive sorting algorithm that sorts an array or list by repeatedly selecting a small or minimum or maximum value, smallest or largest value. It works in place, meaning it requires only a small, constant amount of additional memory space. It only takes small amount of space. Next, why it is used. The algorithm is easy to understand and implement, so we need to use selection sort. Why is it used? The algorithm is easy and understand and implement, so we need to use selection sort, making it is a good choice for educational purpose. The selection sort makes a minimum number of swaps, which can be beneficial when the cost of swapping is high. It can be efficient for small data sets when the data is nearly sorted. This is all about why selection sort used. Next, we move on to the key characteristics. It is an in-place sorting algorithm, meaning it requires a small or constant amount of additional memory space. It is not a stable sort. Equal elements may not retain their relative position. Next, we move on to the application. Applications of selection sort. Where it's used. We need to use it in the educational purpose. Next, we need to use it in the embedded system, in system with limited resources where simplicity is more critical than speed. Time systems also we need to use the selection sort. Next, we move on to the algorithm. Start with the first element of the array as the current position. Let's call it as I. Start with the unsorted list. They divide the list into the two parts, the sorted and unsorted. Initially, when the sorted part is empty, now sorted part is empty. Set the minimum value or current minimum value. Finding the minimum value in the unsorted list. Next, we need to iterate through the unsorted part of the list to find the smallest element. Next, we need to swap with the smallest element found with the first element of the unsorted part. We need to swap first element and smallest element. Repeat the move the boundary between sorted and unsorted parts. Now, sorted part is like one, the unsorted part is another list. When you have proceed all elements, move to the next position by incrementing I and repeat steps 2 and 4 until you reach the end of the array. The array is sorted when you have proceed all the elements in the form of ascending order or descending order. Let's take another one real life example. The finding the best candidates in a job recruitment process. A recruiter may go through the resumes to find the best candidate. They keep track of the best candidate found so far and place it with the next best candidates as they go through the list. This is the example for selection sort. And also another example, sorting a names in the list. When sorting a names list of names alphabetically, you could use a selection sort to find the smallest name and move into the front, repeating the process until the list is sorted. This is all about real. Next, we move on to the visualization of the selection sort. This is the visualization of selection sort. I take the numbers 29, 10, 14, 37, 14. The first smallest element is find the minimum element, then swap with current element until the list is sorted in ascending or descending order. This is the visualization of selection sort. I need to take one example. This is the example. The 64, 25, 12, 22, 11, 10. This is the list. List contains some elements 64, 25, 12, 22, 11, 10. First, we need to start from the element at index 0. This is the current element. This is the current element. Next, I need to find the smallest element in the rest of the array, which is unsorted. The smallest element in the unsorted list is 10. So, I need to swap with current element and minimum element or smallest element. So, in the 64 place, I need to place 10. Need to place 10. In the 10th place, I need to place 64. This is the sorted part. Now, the elements to be sorted. This is the sorted part. These are the unsorted part. These are all the unsorted part. The next current element is the after swapping we need to get 10, 25, 12, 22, 11, 64. Next, move to the next element. Now, I take this as the current element, 25 as the current element. Next, I need to find the smallest element in the unsorted list. The next smallest element is 11. So, the smallest element, I need to swap with 25. In the 25 place, I need to write 11. Write 11. In 11 place, I need to write 25. So, now this is the sorted part. 10 and 11 are the sorted part. 12, 22 and 25, 64 are the unsorted part. Next, I need to take next element, that is 12. 12 as the next element. I need to find out the smallest element in the unsorted list. The smallest element in the unsorted list is 12. Now 12 is already sorted. Right. Next, move on to the 22. Next, now the sorted list is 10, 12 and 10, 11 and 12. 10, 11, 12. The unsorted list is 22, 25 and 64. Now I need to take next element. 22 is the next element. Next I need to find the smallest element in the list. So 22 is the smallest element. This is also already sorted. No need to do this. Now the sorted part is 10, 11, 12 and 22 are the sorted part. The 25 and 64 are the unsorted part. Unsorted list. Now move on to the next element, that is 25. The 25 is the current element. Now I need to find the smallest element in the unsorted list. In the unsorted list 25 and 64, the smallest element is 25. The 25 is already sorted. After 22 it will be a 25, right? So no need to do. Next move on to the 64. 64 is the current element. It is the highest value in the list. So it is in the correct position. No need to do. This is all about the how selection sort works. We need to compare each value with smallest element. Traversing of the list, the maximum or minimum element found. Maximum to minimum or minimum to maximum. Next, I need to take another example. The current element, the current list is 9, 4, 6, 2, 8, 5, 3. Now, the current element is 9. Start from the element 9 at index 0. The 9 is the current element. We find the minimum element in the array. 2 is the minimum element in the array. What I need to do is I need to swap current element with minimum element. That is, current element is 9 and minimum element is 2. 2 swap with 9. After swapping, I need to get this array like 2, 4, 6, 9, 8, 5, 3. 2 is the sorted part. 4, 6, 9, 8, 5, 3 are the unsorted part. Next, I move on to the next element. That is, the current element is 4. After swapping, the 4 is the current element. The next 4 is the current element. Same. First, I need to find the minimum element in the unsorted part. The next minimum element is 3 in the unsorted array. I need to swap with 4 with 3. These, in the place of 4, I need to put 3. In the place of 3, I need to put 4. Now, the sorted part is 2 and 3. The unsorted part is 6, 9, 8, 5, 4. 2 or 3 are sorted. No need to touch this because already sorted. The next current element is 6. Find out the minimum element in the unsorted part. The third minimum element is 4. The next element is 4. Now I need to swap 6 with 4. After swapping, 2, 3, 4 are the sorted part. 9, 8, 5, 6 are the unsorted part. Next, 9 is the current element. Then the fourth minimum element is 5. We need to swap 9 with 5. In the place of 9, I need to put 5. In the place of 5, I need to put 9. So, 2, 3, 4, 5 are the sorted part. 8, 9, 6 are the unsorted part. Next, the current element is 8. Find out the smallest element in the unsorted array or unsorted part. The smallest or minimum element in the unsorted list is 6. Swap 8 with 6. In the place of 8, I need to put 6. In the place of 8, I need to put, in the place of 6, I need to put 8. These are all the sorted part. 2, 3, 4, 5, 6 are the sorted part and 9 and 8 are the unsorted part. Next current element is 9. So, what I need to do is find the smallest element in the unsorted part. The unsorted part is 9 and 8, right? The 8 is the minimum element. Swap 9 with 8. After swapping, the in the 9th place, I need to put 8. In the 8th place, I need to put 9. Now, maximum value in the last index. 9 is the maximum value. 2 is the minimum value. Now, finally, array is sorted in the ascending order. The final array will look like this. 2, 3, 4, 5, 6, 8, 9. It's all about how selection sort works. If you like this video, please don't forget to subscribe, like and share and comment in this video.